Hello everyone, it is Mr. Spinelli here to talk about solving equations by factoring. And what I'm going to focus on is exploiting the property known as the zero product property. And what the zero product property says that if you have two numbers, let's call them A and B, if they're multiplied together and they equal zero, then either A is zero, B is 0, or both numbers are 0. So that's going to come in handy when we factor equations that are set equal to 0, because then each of those factors will be set equal to 0 respectively. So let's take a look at a basic example. So I've got this already in factored form on the left side. Now based on the zero product property, either x plus 9 can equal 0, I'll write that out, x plus 9 equals 0, or x minus 4 can equal 0. Now these are two very basic equations. On the first one I subtract 9, so I get negative 9. 0 minus 9 is negative 9. And on the next one, 0 plus 4 gives me 4. So I'm doing the opposite operation to both sides. And I get my two x values of negative 9 and positive 4. This is called using the zero product property to solve an equation. Let's take a look at another. Okay, these series of three questions are all very similar. They're already in factored form. All I need to do is set each of the factors equal to 0. So when I set the first one equal to 0, you're going to subtract 3 and then divide by 2. So I should get negative 3 halves. The second equation, 5x minus 7 equals 0. You're going to add 7 and divide by 5. So you should get 7 fifths. So we can write that x equals negative 3 halves or 7 fifths. Now in the next one, it's a little tricky because you see there's a 7 out front. There's this constant. So what I can do is, since it's a constant, I can just divide both sides by 7. And because 0 divided by 7 is 0, I really end up with the problem 5x minus 3 times negative 2x minus 1 equals 0. So that constant out front doesn't affect that if either of these or both are 0, that 7 times either of those zeros will still give me 0. So that constant out front does not affect anything. Now if I solve each of these, the 5x minus 3 set equal to 0, I'm going to add 3 and divide by 5. And then for the negative 2x minus 1, I'm going to add 1 and divide by a negative 2. So I get negative 1 half. Now, on this very last problem, this is where I want you to notice the difference between the two that you see on the screen right now. On the last one, there's an x in addition to the 9. Now I can divide both sides by 9, so I divide this whole side by 9 and this whole side by 9, and I get 0 on the right, but that x is still out front. Now, in this case, I have three different factors to set equal to 0. I've got x, which means x equals 0 is one of my solutions. I've got 4x plus 7. I'm going to subtract 7, divide by 4. And I've got 3x plus 8 as my last factor. So I'm going to subtract 8 and divide by 3. So those are my three solutions. So whenever x appears on the outside of your factored form, x equals 0 will be a solution. On the other hand, if you just have a constant, x equals 0 is not going to be a solution unless you have a lone x sitting in here. But those had x's being multiplied by something and added or subtracted by something. So again, if x is on the outside, like in this one, you will get an x equals 0 solution. Now those are all nice because everything is factored for you. So let's take a look at these two. Again, you should always be pausing the video and trying these before I do. Now the key first step in all of these is to get the left side or right side, have one of the sides be 0. Then we are able to factor. So I'm going to be factoring this left side to make it look like those problems before. So what I notice is that both of these constants, these coefficients, are divisible by 14. And the smallest exponent for r is 1, so I can factor out an r. So when I divide 14r squared by 14r, I'm left with an r. And then negative 182r divided by the 14r that I factored out gives me 13 and a minus 13. So now I've factored the left side. The right side still remains 0. I set this portion equal to 0, which is really just setting r equal to 0. Well, then r equals 0 is the solution. And then I'm setting r minus 13 equal to 0, which gives me 13. So again, these are the steps that I'm doing. Set each of the factored forms equal to 0. If I want, I can put this 14r in parentheses so it looks more like what I'm used to seeing. Set the things inside each of the parentheses equal to 0. So on this one, I divided by 14, and I got r equals 0. This one, I added 13, and I got r equals 13. Combine those two results together, and you get your solution. All right, let's take a look at the next one. Looks a little messier. Numbers are a little bit more going on. We got 3 terms now. This is a quadratic trinomial, which you're used to seeing when you factor. So the first thing I notice is that I've got a GCF of 8. So I'm going to factor out 8. So I get y squared minus 6y minus 40 equals 0. And I'm going to do what I did early on. I'm just going to divide by 8, and you're going to see me not show this step going forward. When I divide both sides by 8, I really just end up with the y squared minus 6y minus 40 equals 0. So this 8 out front doesn't really contribute to what my solutions to my equation are going to be. I really care about what this is going to factor into. So now I'm thinking of my factors of 1 and 40, of 40, and I got 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So back to our factoring rules, I notice it's a negative 40, so I know one of the factor pairs needs to be negative, and they need to add to make a negative 6. So I'm looking through. These ones are the ones that have a difference of 6, so I'm going to be using 4 and 10. Now, I want the 10 to be negative because I want to result in a negative 6 when I add the 4 and the 10 together. So then this factors as y minus 10, y plus 4. And again, this still equals 0. I got to keep writing that equals 0, otherwise my equation becomes an expression. Equations have an equal sign. Now I'm going to set the first one equal to 0, and I get y equals 10. Set the second factor equal to 0, and I get y equals negative 4. So my two solutions are 10 and negative 4. Okay, so the key is I've got to be able to factor these things. Let's take a look at some more. All right, now you notice that the right side doesn't equal 0. So my first step is to get 0 on one of the sides. I'm going to get 0 on the right side. It doesn't matter. So the first one, I'm going to do 7x squared plus x, and I'm going to subtract the 6 from both sides. So now I've got a polynomial on one side and 0 on the other. Now I know that the factors of 7 are just 1 and 7. So I know this factors as 7x and x. And I've got to think of my factor pairs of 6, which are 1 and 6, and 2 and 3. So what I notice is that if I multiply the 7 by a 1 and the x, so the 7x times a 1 and the x times 6, the difference between 7 times 1 and 6 times 1 is a difference of 1. And since I want this to be positive, when I add them together, I need the 1 to be positive, and I need the 6 to be negative. So I needed one of them to be negative because I had a negative 6, and they needed to add up to be positive 1. So then these two factors set equal to 0. The first one, I'm going to add 6 and divide by 7, so I get positive 6/7. And the second one, I'm going to get negative 1. And that would be my solution, 6/7 and negative 1. All right. Next one, I notice the 760n on the other side, so I'm going to subtract it from both sides to bring it to the left. And I'm sandwiching it in between the two terms that were already on the left because I want it in standard form to help me factor. Now I notice these have a GCF of 10. So if I divide everything by 10, I'm really just cutting off that 0 at the end. Now things I notice, I want to multiply to make a positive 20, but I want to add to make a negative 76. So I got to think of my factors of 20. Got 1 and 20, 2 and 10, 4 and 5. So I've got 3 factor pairs, which give me a total of 6 combinations so far. But since they need to multiply to make a positive, add to make a negative, I know they're all going to be negative. So it's going to be a minus problem. Now, I'm going to get rid of the 10 because it doesn't matter. So I'm ultimately trying to factor this and set it equal to 0. So this can be 21n and n. And again, I know it's going to be a minus because it's got to multiply to make a positive, but add to make a negative. Or it's going to be 7n minus something and 3n minus something. Now I notice that when I multiply 21 by these numbers, it's going to be very large. So probably the only one I'm going to consider, they're all just too big, because 21 times 4 or 5 already sends me up above 80. And I won't be able to subtract enough to get down to 76. So since I know it's a minus, I notice that 10 and 2 will work, because 7 times 10 is 70, and 3 times 2 is 6. 70 and 6 add to make 76, and they're both negative. So now I'm setting each of these factored pairs equal to 0. First one gives me add 2, divide by 7. Second one gives me add 10, divide by 3. So my solutions are 2/7 and 10/3. Alright, so this is mostly just practice of factoring. Alright, now I got another one. Now there's just more terms on the other side, which is perfectly fine. Does not scare me. So I'm going to move them to the left by subtracting them, because they're both positive on the right. So now I'm ready to factor. So this can either be 21x and x, we just saw 21x squared, or it can be 7x and 3x. Now I need to think of my factor pairs of 16. I've got 1 and 16, 2 and 8, and 4 and 4. Now they need to multiply to make a negative, so one of them is going to be positive, the other one's going to be negative, and they need to add to make a negative 10. What do we think? Well, if we look at the 2 and the 8, those look the most promising. But that's going to be too large, so I'm probably not going to be looking at the top one. I'll probably be looking down here. Let's see why. 7 times 2 gives me 14, and 3 times 8 gives me 24. Those have a difference of 10. And since I want it to be a negative 10, I've got to make the 8 negative and the 2 positive. So now these things get set equal to 0, but this is my ultimate factoring. So I'm going to add 8, divide by 7, subtract 2, and divide by 3. Okay. Last one on this sheet. Going to subtract the 4 to move it to the left. Which then gives me 0 on the right. This is a nice one because I know it can only factor into 2z and z. Think of my factor pairs of 4, 1 and 4, 2 and 2. Since my coefficients on z have a difference of 1, well, first of all, I know I want to multiply to make a negative 4, so they both got to be positive. And then I'm going to be using the 4 and the 1. Why this? Because 2 times negative 4 gives me negative 8, and 1 times 1 gives me positive 1. Set this one equal to 0. I'm going to subtract 1, divide by 2, and on the second factor, I'm simply going to add 4. So there are my solutions. All right. Now, here's a very common one that some people can very easily mess up. A temptation is often to just divide both sides by 12r, but again, we should always be thinking of adding and subtracting to get 0 on one side. Because if you divide by 12r, you get 1 on the right side. But it's usually more convenient when solving equations to get 0 on one side. So I'm going to subtract 12r. Actually, I'm going to do this backwards just to show you that it doesn't really matter. So I'm going to subtract the 10r squared. So I got 12r minus 10r squared. Now I notice both of these numbers are even and they both have an r, so I'm going to factor out a 2r. So 12r divided by 2r is 6. Negative 10 divided by 2 is negative 5, and I still have an r left over. So now I've got to set 2r equal to 0. Well, that gives me r equals 0. And I've got to set 6 minus 5r equal to 0. So I'm going to subtract 6, but divide by a negative 5. So a negative divided by a negative gives me a positive. So I get 6/5. And you would get the same answer if you subtracted 12r to start. All right, now I got a little bit bigger numbers. Still the same process. I'm going to add the 225x to get it to the left. I'm going to add the 54 to get it to the left. All that equals 0. Now if I add 1, 2, and 6 together, I get 9, which is divisible by 9. By 3. If I add 2, 2, and 5 together, I get 9, which is also divisible by 3. If I add 5 and 4 together, I get 9, which is also divisible by 3. So I know all these things are divisible by 3. And if I divide the first one by 3, I get 42, which I know is also divisible by 3. And if I divide the second number by 3, I get 75, which is also divisible by 3. If I divide 54 by 3, I get a number that's also divisible by 3. So all these are technically divisible by 9. So if I factor out a 9, I get 14x squared plus 25x plus 6 equals 0. So again, I don't care about the 9 because it's just a constant. So technically it's going to go away when I solve. So I'm trying to factor this. Now this can factor as 14x and x, and it's going to be plus because everything is positive, or it can factor as 7x and 2x. So I've got to think of the factor pairs of 6, which are 1 and 6, and 2 and 3. Well, I know that since everything's being added, let's see here, 7 times 3 will give me 21, and 2 times 2 will give me 4. 21 and 4 add up to make 25. So set the first one factor equal to 0. I'm going to subtract 2, divide by 7, subtract 3, divide by 2, and those are my results. Alright, so we're getting lots of factoring practice as we use the zero product property to solve equations. Alright, so now I got one where I've got a 3 on the other side. Well, I want to subtract the 3 from both sides in order to get 0 on the right side. Now I notice all these numbers are even, so I'm going to divide by 2. So yeah, one thing I can be doing if I write this out a different way, I'm just going to divide both sides by 2 instead of factor out a 2. That's another way to think of it. So then I've got 5x squared minus 52x plus 63. 0 divided by 2 is 0. Now this factors nicely. It's either a 5x and an x and nothing else. So I think of my factor pairs of 63. Got 1 and 63, 3 and 21, and 7 and 9. Now I need to add to make a negative 52 and multiply to make a positive 63. So I know both of these are negative. If I multiply the 5 by 9, I get 45, and the 1x times 7, I get 7. So negative 45x and negative 7x add to make that negative 52x. So on the first one, I'm going to add 7, divide by 5, and the next one I'm just going to add 9. And there are my results. So again, goal is factored form, apply the zero product property. Now this one I've got terms of all degrees on each side. I've got a squared, just an r, and then a constant. So I'm going to move everything to the left just because I've got a bigger r squared on the left, and I want my r squared term to be positive so I don't have to factor out a negative, just to make my life easier. So if I subtract 3r squared, I get 45r squared. Subtracting a negative 8r or adding 8r, I get 24r. And then subtracting 8, I get negative 36. Now I notice all of these numbers are divisible by 3 because their digits add up to something divisible by 3. So I'm going to factor out a 3 or divide both sides by 3. So dividing both sides by 3, I get 15r squared plus 8r minus 12 equals 0. So I've got to multiply to make a negative 12 and add to make an 8. Factors of 12, 1 and 12, 2 and 6, 3 and 4. So I know this factors into 15r and r, or 5r and 3r based on my factor pairs of 15. So as you've been practicing, you should get negative 2 with the 3r and positive 6. So 5r times the negative 2 gives me negative 10. 6 times the 3r gives me positive 18. 18 minus 10 gives me that positive 8r in the middle that I wanted. First factor, I'm going to subtract 6, divide by 5, add 2, divide by 3. So hopefully you've been trying these on your own just so you can get that factoring practice. Because I think once you've factored it, you notice these problems get very, very easy. Now I've got one that's a little bit different. We've got no middle term, if you will. We just have an x to the fourth, which is really x squared squared. And we notice that these coefficients, 9 and 121, are all perfect squares. So this one is a perfect square. It's a difference of squares. It's going to factor into 3x squared plus 11 and 3x squared minus 11. And I'll show you how to do this one a different way too, if you're interested. So now, if I set each of these equal to 0, so I've got 3x squared plus 11 equals 0, and 3x squared minus 11 equals 0. So I'm going to subtract 11 and divide by 3, and I get negative 11 thirds. On this one, I'm going to do the same thing, but I'm going to add 11, divide by 3. Well, next step says I should square root. So x equals plus or minus the square root of negative 11 thirds. Well, that one won't come up in your calculator. There is an answer, but it's not to be discussed in Algebra 1. It's an imaginary number, a complex number. So I get x equals plus or minus the square root of 11 thirds. And your calculator would spit that out as some decimal number. Okay, so that is how I'd solve the first one. The next one, I'm going to show you the two ways to do this. So like I said, it's often best to get 0 on one side of your equation. So I'm going to subtract the 81 from both sides. Now I notice that the square root of 36x squared is just 6x. And the square root of 81 is 9. So I'm going to add 9 and subtract 9. So why does this method work? Since I want there to be no middle term, I need these coefficients to be the same, and I need these constants to be the same but opposite sign. That helps me cancel out that middle term. There's no x. There's an x squared and a constant. So now I set each of these equal to 0. So I'm going to subtract 9 and divide by 6, or I'm going to add 9 and divide by 6. So I get plus or minus 9/6, or really plus or minus 3/2 if we reduce that fraction. Now another way I can do this is I can start by dividing both sides by 36 because it's a constant. I can always divide by constants whenever I want without really too much concern of running into a problem. Now my rule says I can usually just square root this. Remember when I square root I get a plus or a minus? Square root of 81/36 is equal to the square root of 81 over the square root of 36, which is simply 9 over, oops, we don't need the square root anymore. I already performed that operation. 9 over 6, and you end up going right back to where you started. So thank you for watching, and have a wonderful day.